In this video, we're going to look at constructing equations of tangents to circles. So here is an example. We're given an equation of a circle, and that is given in the first general equation of the circle, which, if you remember, is given by x minus h squared plus y minus k squared is equal to r squared. Now, what we know about that equation is that k represents the centre. So the centre is HK and the radius is given by the letter R. So looking at R's here, our equation, we can see that the minus comes from the formula itself. So that became a plus, meaning our H must have been a minus 3 and our K must have been a minus 4 because that is also a plus. What we also know then is that the radius is given by r squared here, so we can get that back out. We know that the radius squared here gives us 25, so we know that the radius of this circle is equal to 5. So we've gotten the key pieces of information out, which is the centre and the radius. So we now know what that circle looks like. The tangent then is a little bit trickier. So the tangent they're telling us is at the point 0, 0. Now what we know about tangents is that they are lines, and lines are given by the general formula y minus y1 equals m into x minus x1. So what do I need to be able to use this is first I need a y1 and an x1, and we know y1 and an x1 means we need a coordinate point, which we actually have already, so I could actually use that piece of information. So I have y minus 0 is equal to m into x minus 0. So what I've gotten so far is y minus 0 is just y, m into x minus 0, which is mx, like that. So m then, if you think back, m is actually the slope of the tangent. So how are we going to get the slope of a tangent here? So the slope is given by the formula y2 minus y1 over x2 minus x1, but the problem here is that we only have one coordinate point. But if we sketch out our circle and our tangent, what I will get is this sort of a picture here, and I will have my centre here and my tangent here at 0, 0. And what I know about a circle and a tangent is that the circle radius meets the tangent at a 90-degree angle. I know that they meet at a 90-degree angle, so I know that they are perpendicular. Now, do I know anything about perpendicular lines? Well, yes. We know that perpendicular lines, if you have slope number 1 and you multiply by slope number 2, we get minus 1. So if I can find out this slope here, I might be able to find out the slope of this line. Now, what would I need to find the slope again? I would need to have a coordinate point here and a coordinate point here. I have this one up here. I have this we know to be 0, 0. And this coordinate down here we actually know because it's the centre of the circle, and we worked that out earlier to be minus 3 minus 4. So I'm going to put that in here. So minus 3 minus 4. So I can actually work out the slope of that line there. So the slope of the radius, I can work that out there. And that is again given by the formula y2 minus y1 all over x2 minus x1. And what we can do with that then is we can say, okay, this one is x1, y1, this one's going to be x2, y2. So I'm going to sub that in. So I'm going to have y2, which is going to be 0. I'm going to have minus y1, so minus 4. So I'm going to be extra careful subbing that in, put it in a bracket for myself. Then it's going to be x2, which is 0, and it's going to be minus 3 again. So I'm putting that in a bracket to be extra careful. What I have then is I have 4, because it's going to be positive, all over 3. Now that is the radius, the slope of the radius. And what I know is that the radius meets the tangent at a 90-degree angle. In other words, they're perpendicular lines. And what I know then is that perpendicular lines, what I can do to get the slope of my tangent, I'm going to call it MT. Perpendicular lines, flip that slope, so it becomes 3/4, change the sign. So it becomes -3/4. So I can fill that in now because I know that to be the slope of my tangent. So here we have the slope of our tangent, which we can fill in up here. We've now found out what it is. So I didn't need to use this formula, not for the tangent, but for the slope of the radius, which I know then is perpendicular. So we work that out to be -3/4 by x. So there is the equation of the tangent to this circle through the point 0, 0.